Hello, everyone. Welcome to the final presentation presented by Zihao and Vinci. We're talking about human resource data analysis. Human resource data analysis are important for both employee and employer. For employee, they can know what are the characteristics for them to behave to get promoted, and for employer, they can know how well their employee performs. So we did some exploration on the data side. So first of all, we combine the two data sets using the join function. And then we group the data set by positions. We count how many people are there for each position and their average hourly pay rate for each position. And then we make a distribution. We look at the distribution of employees' pay rate, and we find that it is not normal. It is bipolar. So we can see that there are two clusters. The first cluster on the left are perhaps the lower level worker, and the cluster on the right are the managers. And lastly, we did explorations on the scattergram and plot the scattergram between special projects versus the pay rate, and we can see that there is a clearly positive linear trend between these two variables. So we have two research questions. First, we are curious about will the employees from this company have a higher pay rate compared to the average American hourly pay? And we are also curious about how pay rates behave when special projects come various. So first, to tackle our first research question, we did a hypothesis testing. Our null hypothesis is that the employees in this company will have the same hourly pay rate as the average pay rate of United States employees. And our alternative hypothesis is that the employee in this company will have a higher hourly pay rate than the United States average employees hourly pay rate. We choose a significant level of 0.05, and we conduct a Z-test. Our test statistic is the average American hourly pay rate, which is 29.7 according to the United States Bureau of Labor Statistics. Our result of this hypothesis testing is quite promising. We find the 95% confidence interval, and we find that our test statistics doesn't fall into this confidence interval. We also compute the p-level. The p-level is 0, which is greatly smaller than our significant level 0.05. Therefore, we can conclude that we have enough evidence to reject our null hypothesis and accept our alternative hypothesis that employees in this company has a better hourly pay rate. We want to tackle our prediction question, how pay rate behaves when special project counts varies. So from the scatter diagram, we can see a positive relationship between special project count versus the pay rate. So the correlation between them is actually 0.4. Based on that, we did a linear regression in between these two variables and plotted the regression line. We also plotted the real pay rate versus the predicted pay rate. And then we did some analysis. We calculate the residual by taking the difference between the actual pay rate and the expected pay rate. And we plot a scattergram between the residual and the special project counts. And we find that the correlation between the special project count and the residual is almost 0, which shows that our linear regression model works. Because our linear regression model is good and it works, so we gave a prediction on the expected pay rate for all the special project count among 0 to 20 to take it as a prediction. And lastly, we find an interesting fact. While we are doing the analysis, we want to see what is the greatest residual. And we end up finding the greatest residual being the president and CEO of the company, which makes sense because the president and CEO of the company don't need to do any project, but they get a very high pay rate. In conclusion, we find that the hourly pay rate of employees in this company is higher than the average hourly pay rate of Americans. We also find that there is a positive relationship between the special project count versus the pay rate. One limitation of our project is that the sample does not cover an even distribution of people from different occupations. Therefore, some of them may give weights more than others in our linear model. We can better optimize this by collecting more samples.